Alright, so formulas. A formula is an equation that represents a general relationship between two or more quantities or measurement. Now, basically, solving formulas, or a formula would be considered a literal equation. A literal equation is an equation that has more than one variable in it. Now, just how we practice solving linear equations, the steps where we may have to add or subtract numbers on both sides, or we have to divide, we have to distribute, we have to multiply by the LCD, we would do the same thing here. Okay, but it's just not one variable, one consistent variable, and then we have numbers. Here you have different variables. So for example, we have something such as let's see, x plus y is equal to z. And I want you to solve for y. Okay? Well, when you come across a literal equation, all we have, or a formula, now this isn't a formula that we would work with, the distance formula, d is equal to r times t, we can change that particular equation up to make it work for us. If we're looking for, and I'll write it up here after we do this example, but if we were looking for time, okay, well, we can convert that equation to where it will equal to t, okay? So, how I understood, and when I was a student, I was in your shoes and all of that stuff, but how I made myself understand it, the variable that they're asking us to solve for is not the variable that I would recommend that you move first. Okay? So, I'm solving for y, meaning I want y by itself. What variable's on the same side, or if it's next to y, that's the variable that we want to move. Either we're going to add or subtract, or we're going to multiply, divide. Okay, well, the variable we want to move over is this x. How would we move it over if the x is originally positive? We're going to subtract. Okay, so we're going to subtract x to both sides, and we have y is equal to z minus x. Don't place the variables together and say negative zx. These are terms. They're separate. They're not like terms, so you want two separate entities, two separate variables, and represented as such. Here you go. D is equal to R times T, and we're solving for R. Well, given the distance, given the time, and we want to find the rate, well, we can convert this distance formula. This is R times T. R is what we're solving for, so that's not the variable that we want to choose or that we want to move first. So which variable we're going to move, and how will we move it? Yes. Divide T to both sides, and we have D over T is equal to R. Two y plus 5x is equal to 10, and we're solving for y. So it's just not y right now, it's 2y. That variable term, I want it to stay there for right now. Okay, so, well, since we want to keep 2y, I'm going to move the 5x. How will we move the positive 5x? Subtract. Now, please do not subtract 10 and 5x, because what? They're not like terms. Someone would, because the purpose of, well, the reason behind this, more practice with solving linear equations, but you're not going to come up with an answer of 5, 10. You're not going to come up with the numerical answer, and I shouldn't say you're not going to, because there are some literal equations where you may end up with a numerical answer. But for the most part, since we're talking about literal equations, more than one variable in the equation, then you need to have those consistent variables in it. Okay? Yes, sir.
It would be better if you didn't write the 5 up under the 10. They just put out the 10 minus 5x.
Yeah, we could, and I'm going to do that, but
Just saying that would be.
so it's not so confusing. Yes, I do understand that. Okay. And if I had enough room and could have spaced it such that I could have done it that way. All right, now our last step is to do what? Divide by 2 to both sides. So we have 10 minus 5x all over 2. Okay, now you see, well, could we divide 2 into 10? Okay, we can. Now, if you choose to do that, you also have to divide that 2 into the 5x. You get to this point, I'm very happy, because then I can take you to the next point. Okay, now, does it matter in my math lab? No, it doesn't. If you stop here and put this particular solution in there, it's not going to mark it wrong. But we can go a step further. So, keep going. Okay, where we want to divide this 2 into the 10. You just can't say 5 someone may say 5 minus 5x. Well, you're dividing the 2 into the 10, you're dividing the 2 into the minus 5x. So you're going to write it as 2 separate fractions. 2 separate fractions. So once you write it as 2 separate fractions, then you can divide that 2 into the 10. Y is equal to, we have 5 minus 5x over 2. And like I said on Monday, when you come across a fraction it's an improper fraction, just leave it there. Don't change it to a decimal. Don't change it to a mixed number. Just leave it as a fraction and make sure it's reduced to lowest terms. Any questions with this one? This third example. Number 4, we have here P is equal to 2D plus 2C, and we're solving for D. Okay. Well, 2D we're not going to move just yet, but we can move the 2C by subtracting. P minus 2C is equal to 2D. Then the last step would be to do what? Divide by 2. So we have P minus 2C over 2 equals to D. And if you want to take it a step further, which we will, especially when we get into graphing and converting linear equations into variables in slope-intercept form. Okay, we can write it as 2 separate fractions. I'm going to put or. You get this right at this point, I'm very happy. Okay, but like I said, we can take it a step further, write it as 2 separate fractions, two separate fractions, and then we can divide out those 2's. That's with that 2C over 2. P over 2 minus C equals to D. Okay, so our goal is to solve for G, but G is inside the parenthesis. So first, let's think about our directions when we solve a linear equation. Parentheses are present. We have to use which property? Distributive property. So we're going to distribute the m to the 8 and the m to the fg. So we have T is equal to 8m, because anytime you have a number and a variable, a coefficient and a variable, you put the number first. Okay, you could have said m8, but normally we say 8m. Okay, plus m times fg, so we have mfg. Parentheses are gone. This looks similar to the last example we just completed. We're going to circle the MFG because I don't want to work with that just yet, so we're going to subtract 8m to both sides. T minus 8m is equal to MFG. And then what would be the last step?
MF.
By doing what?
Division.
Yes, dividing. T minus 8m over MF equals to G. And this one we can go further. You stop here. Great. Okay. We can write it as two separate fractions. Again, T over MF minus 8m over MF. What divides out? The m's. Okay. So T all over MF minus 8 over F equals to G. There you go. Any questions with this, the little equations?